Good morning, everyone. Welcome back to the learning of remaining concepts in behavioral abstraction for modeling any hardware design. The next one we are going to discuss in today's session is about conditional statements. These conditional statements you might be very familiar as you have learned in your C programming language, and in many of the basic programming languages also you might have encountered these conditional statements. Let us have a quick recap on what is these conditional statements and how far they will be useful in developing any behavioral abstraction program for realizing any hardware design. These conditional statements generally they are adopted to decide whether or not something have to be executed or not. That means, coming to the programming point of view, a statement should be executed or not is completely relied on a particular condition. So these conditional statements are categorized into three types. One is type 1 statement, type 2 statements, type 3 statements. Coming to the type 1 statement, we don't find else condition. That means we can able to see here only if statement, that is a conditional statement. So whenever that condition is satisfied, the statement following to the if condition will be getting executed. So it will be generally like if expression, if that expression is true and it is meeting the required condition, the corresponding statement, the below statement will be getting executed. So this is about type 1 statements. Like you can able to see here, if negation lock buffer equal to data, that means neg lock. So it is indirectly giving me the meaning that there is no lock. So once there is no lock means the content in this data variable can be transmitted or can be passed to this buffer register variable. Like generally whenever you are opening the lock of your house, you easily can enter inside the house. The same scenario here also, whenever there is no lock, the content of this data register is transmitted to the buffer register. And similarly we do have one more example, if enable out equal to in. That means out blindly follows in when this enable signal is in logic 1 or it is true condition. Coming to type 2 statements. So in this type 2 condition statement, I can able to find if condition as well as the else condition also. So else statement will be available and if statement will be available for execution. That means either of the statements will be getting executed. Okay, so how the syntax will be like, if something, that is expression, will be generally kept inside this parenthesis and followed by a true statement for the if condition, else false statement will be followed. So generally what happens, if let us take the same example, if queue is ready, that means queue is ready. In the sense it is giving me the meaning that queue is vacant. So once the queue is vacant means a data can be entered into a data queue register. Okay, so once the queue is slowly entering into the data queue register, generally its index value will be getting incremented. Like previously, if I consider I am having a data queue, this is of 8-bit register. So this 8-bit register initially is vacant. So slowly 1 bit, 1 bit, 1 bit I am introducing into my data queue register, which is of 8-bit. So previously the first bit will be occupied to the 0th position of data queue, and the next bit will be occupied to first position of data queue, next to second position. In this way the index will be getting incremented for the data queue register. Okay, once the queue is full with its content, that means the queue is no more ready to accept any data, so the true condition or the true statement will never be executed. Else, that means the false statement is getting executed here, that is dollar display queue full, try again. So this is the one what I would like to see in the console window when the data queue register is having full of its content. And the very next type 3 conditional statement is if else. That means I am having here three conditional statement. One is if correspondingly true statement 1 will be executed, else if second one true statement 2 will be executed, else if true statement 3 will be executed, goes on, and the last one I can able to sense here is else. So else the default statement will be getting executed. Like that means in the type 1 statement I can able to find here only if condition. In the type 2 statement I have found if condition as well as the else condition. And in the type 3 statement I have found if condition, else if condition as well as the else condition also. Correspondingly, whenever particular thing is getting satisfied, corresponding statement will be getting executed. You can able to see here if ALU control is equal to 0. This statement, like let me consider this as one statement, 1 will be getting executed. If it is not, that means this condition is not meeting or not achieving, ALU control equal to 0 is not achieving means ALU, let me check for ALU control if it is equal to 1. If it is equal to 1 means I will be executing this statement. If not, if not, I will be checking for 2 and this corresponding statement will be getting executed if neither of the conditions are satisfying. Else by default something have to be displayed in the console window, that is invalid control signal. So these are the three what do you say types in your conditional statements which we use in our behavioral abstraction. But what I feel is in the type 3 conditional statements I have came across many a number of times if, else if like so on, and lastly I came across this else condition. So I feel it is unwieldy, the process is very becoming unwieldy, and I also find that I may have too many alternatives like if, else if. So if many number of alternatives I am having means I have to write the program code in the same manner. So I just wanted to avoid this scenario. To overcome this scenario, what I would like to prefer is to use the case statement now. So what is the purpose of this case statement? Okay, so let me have a quick recap on conditional if. I have taken here 2x1 multiplexer as an example whose inputs are selection line a comma b and output is y. Register y means we are writing the code in the behavioral abstraction. So always, that means structure procedure is required. Always I have to depend on select inputs. Begin if selection, that means if is f of cell. So that means if it is a true, that means selection is 1, logic 1, output is following the a, else output will follow the b variable and end module. So this is one thing. The same if I would like to represent in using the case statement means my programming code will be changing from this line onwards. Like instead of if else I will be directly using the case statement, like how you have a good awareness on using the case statement in the C programming language, the same thing I will be also using here, like case the expression and the case alternatives I will be writing here, and the corresponding execution statements will be written here. So case, end case, end module. This is how we are going to write in using the case statement for 2x1 multiplexer. So like you can able to see here, and this is my case of cell. This is SEL here, nothing but it is a case expression. We call this one as an expression, and this 1 bit binary 0, 1 bit binary 1, we call it is a case alternative. So for each and every case alternative, there will be a statement or a block of statements which we call a multiple statements that are ready to execute if particular case alternative is satisfied. Okay, so if multiple number of statements are there, means like y equal to a, next immediately dollar display the value of y. If I have written, that means two statements are there, so I have to use definitely begin end keywords. Okay, and so yeah, as we discussed, it is unwieldy nested if else if. So because of too many alternatives, so case is the best solution. Okay, so like let me discuss about the case statement once again. This is my expression, these are the alternatives and the particular condition to be getting executed. In the case statement also, we do have some categories in the case, that is case X and case Z, apart from the normal case. So what is the difference between the case statement, case X as well as the case Z? I will explain you in the program. Before explaining it in the programming code, you need to remember one point is case statement will not be getting execute. It won't execute for X and Z in alternatives. Okay, so for example, if case of cell is there, this is my expression, SCL is expression. So in these alternatives, if I have 1 bit binary X or 1 bit binary Z, something is there like that, that means I am going to get a bug in my program, so it will never be getting executed. So like to overcome this one, that means X and Z, if they are present in the alternatives, and if they are present in the alternatives also, my execution, if it should not stop, means I have to use case X statement. So case X condition I have to use, simply replacing this case with case X. So even though if you have having here in the alternative 1 bit binary Z or 1 bit binary X, you will never be having any bug in the design. And so this is about case X statement. That means case X just ignores whatever it is, X is present or Z is present in the alternative, I don't care. That is what it is conveying us. Coming to case Z, so case Z, it only ignores Z in the alternatives, but if it find X in the alternative, again we may have a chance of getting the bug. Now see here, case of cell list. So case X, if I have taken 1 bit binary X, 1 bit binary Z, it will execute. Now instead of that, case Z I have written. Now 1 bit binary 0, next 1 bit binary Z, it will execute because case Z is there. It will ignore Z and it simply executes. So case Z, and here starting 1 bit binary 0, next 1 bit binary X is there, I may have a chance to receive the bug. So the program will never be getting executed. So these are the three kinds of the case statements. So you can see here, this I have written X is, capital X is nothing but here the expression, something, I don't know, it may be a control signal or whatever it is, some X register, capital X is nothing but it is a 2-bit register. So when this 2-bit register, so this is case Z. In the alternatives, I have found Z. That means this first statement will be getting executed because it ignores Z. But coming to second one, it had found x in its alternative, so the code will never be executed. And coming to case x, so it will ignore if in the alternatives I may have x or z, I will execute the code, the program code. That is what it is conveying. Okay, so let us discuss this case statement by using some example. Let me have here a priority encoder or a normal encoder also. I can take here for the example explanation purpose. Okay. So here I am having the case, right? So this is a normal 4x1 multiplexer I am having here. So whose inputs are I0, I1, I2, I3, selection lines are S1, S0, and the output is OUT. So I am structuring this one using behavioral abstraction. So always I need to depending upon the inputs. So always iterate S1 or, so that instead of or I can also use comma, because it is an event or control as I discussed in the previous lecture. If you have any doubt, please go to that. So case of the selection line S1, S0. So S1 is a scalar, S0 is also a scalar. I am appending these two scalars. That means I am going to get a vector, or simply concatenating I am doing here. So if it is 2-bit decimal 0, that means I can write, instead of decimal 0, I can also write as 2-bit binary 0 0, 2-bit binary 0 1, 2-bit binary 1 0, 2-bit binary 1 1. So correspondingly out equal to I0, I1, I2, I3. So this is about case statement. So like for example 2-bit binary 0 0, in this manner also I can write. Instead of 2-bit binary D0, I have written like. For example, as this is my normal case statement, 2-bit binary 0 and X, it won't execute. And similarly, 2-bit binary 0, and Z or Z and 1, it will never execute. We may like face or receive the bug in this line itself only, because case X will not ignore X and Z in its case alternative. That is the thing here. Okay, so this is about case statement. And coming to case X, so as I have said you that case X encoding, because I have taken priority encoder, so encoding, this is my expression. So which is, this encoding is a 4-bit register. When encoding is being assigned with some value, like for example 4-bit binary 1011, so 4-bit binary 1011. So this expression is finding out which alternative is having this these like bits. So 4-bit binary 1011, that means the MSB bit should be definitely going to be 1. Okay, so here, yeah, in this here I have found the MSB bit as 1 because it is the best alternative that is going to be picked. So remaining XXX, so XX indicates it may be a 0 or it may be a 1. So 4-bit binary 1011, so the best alternative that is going to be selected is first one itself, and the output, that is next state, will be equal to 3, will be evaluated as its output. Okay, so instead of this one I may have like this, like instead of X, let me keep Z. So now also the program will be executed without giving us or producing us any bugs. That means here case X generally ignores Z or X if these two are found in its alternatives. That's it. Okay, so this is about case X. Coming to case Z, so case Z only ignores Z in its alternatives But if in its alternative x is found, means definitely we are going to receive some error, syntax error or kind of thing, execution problem, or some kind of thing we have a chance to receive. So you can see here case z a. So here a is nothing but some expression. So what is the expression or variable or a signal or whatever it is we can use. Okay, so like I have used here a, this is a vector of 4-bit capacity, and when a is equal to 4-bit, I'm going to give something 4-bit binary 101 1, let it be like 1011. So what is this MSB1? So among these alternative, this is my best alternative. So not 1011, I would like to give like this one question mark, one more question mark, one more question mark. So question mark is nothing but it is a replica for Z symbol. So 4-bit binary 1 question mark question mark question mark. So this alternative will be evaluated. I mean the first alternative will be evaluated and this P code will be produced as an output instead of this one. So for example, if either in my case expression, that is in A, or in my case alternative, if I have found X, I may receive the bug here, 1 question mark X and question mark. So the program will never be getting executed. Otherwise, if I have X in my alternative, still the program will never be getting executed. Only the thing you need to remember is case Z ignores only Z. It won't ignore X in its expression or in its alternative. That's it. That is the one you have to remember. Okay, now let us see some of the what is the next topic here? Yeah. So priority encoder we have completed. Next is loop statements. So in any of the programming language we generally use loop statements for many number of activities. Without loop statements there won't be any programming language, I can say. Like in our Verilog HDL also we do use 4 types. We have here 4 loops. One will be a while loop, for loop, repeat and forever loops. So these must appear only inside your always or initial blocks only. Okay, so let us discuss about each and every loop one by one. Now the first one is the while loop. Of course you know that a while loop executes until the while expression is false. So here while I am having a while loop, it is the expression for the while loop. Whatever I am writing in the process, this is the expression until this expression is false. Like when count equal to 11, for suppose 11 is less than 10, that means it is a false. So until this expression is false, it is getting these statements will be getting executed. That means when these statements will be getting executed, when this condition is true, when this expression is true, until and unless this expression is false, it will be continuously getting executed. Once this expression is found as false, these statements will never be getting executed. So that is the purpose of your while loop. So next one is we do have here a loop, that is a for loop. So generally we have the syntax for the for loop, which is divided into 3 parts. One is initial condition or initialization of a variable. So the next one is like some kind of condition we are going to place, like terminating condition I can say here, that is count is less than 10, and next is some kind of incremental statement or procedural assignment, like count equal to count plus 1. It is nothing but some kind of a procedural assignment only, or an incrementing statement. So this is the format for your for loop. So for count equal to 0, that means initialization. I'm doing initialization for count variable. So when count is less than 10, of course it is less than 10 only because it is 0. Now after that one, this will be getting executed and count value will be getting incremented. This is about the for loop. Okay, the next one is I am having here the repeat. So what is this construct in the behavioral abstraction? As in some of the programming languages we may not even see the repeat construct, right? So here, like how the while and for loop are there, the repeat is also a loop. This loop will execute only a finite number of times, because like how I am saying it is a finite number of times means who is taking the responsibility for that finite times of execution means whatever the thing that we are going to place in this braces or in this expression, that expression only will be taking care of that. So this repeat construct, what happens, must definitely have an expression, that is repeat of count. This count is an expression. It may be a number, it may be a constant, or it may be a variable, or it also be like a signal value also. Like for example, if I am having count equal to 120, or count equal to 5, or count equal to 20 for suppose, that means this statement sum equal to sum plus 5 will be getting executed for 20 number of times, as count equal to 20 I have taken here. So this is about repeat loop. Okay, because only the thing I am concentrating or focusing is only the part in your program, because I didn't like written here what is the prior instructions and what are the successive instructions after these two. Okay, so only a slice in the program only I have taken to demonstrate you how the repeat construct have to be used in your Verilog HDL language. Okay, so remaining thing, whenever you are doing the programs, you can able to understand what is this sum equal to sum plus 5. Like someone will be initializing sum equal to 0, initial sum equal to 0, so repeat of 20. Now sum equal to 5, next repeat of 1, sum equal to 5, 10, sum equal to 20, sum equal to 30. In this way, up to 20 number of times the sum will be getting executed. That's it. And the last one is the forever loop. So what is this forever loop? It is just like as you might have encountered always. So the same principle will also work here also. So this forever loop doesn't contain actually any expression, as you can able to see in while loop, for loop and repeat loop. It doesn't have any expression, but this loop executes forever, always. That means forever, continuously it keeps on executing until and unless someone is placing $finish. Okay, once $finish is encountered, the execution will be getting terminated. So this is nothing but the loop, like while loop I can say, that will be having some expression that always evaluates to true. Like we do have here while of one, indefinite loop we generally call. So to come out of this indefinite loop, we use $finish statement. Or sometimes instead of $finish we can also use disable. It is a keyword in your Verilog HTML language. I didn't written here. So that one also I can use. A disable statement can also be used here, because here in the code itself, forever the clock is continuously getting toggled. So initially clock equal to 0, after 10 seconds clock equal to 1, or next 10, after 20 seconds clock equal to 1, 0, after 30 clock equal to 1. So it is just like always the activity is continuously advancing in the simulation. So if I want to stop this activity, I definitely have to use $finish or some kind of a disable statement after this one, after the forever. Okay, so this is about forever loop. Okay, the very next one is block statements. Let me check out. I did have, yeah, in loops also I have written the same thing. Yeah, once you can able to see here, this is about while loop, and this is about for loop example. From here, this is about for loop. No need to explain, because you are having a good skills in programming, so you can able to analyze what is happening here. And because in the PPT slides I have taken only a slide in the program, like for a repeat loop I have taken only this much portion of your program only, but here I have displaying you the entire program structure. And the last one is forever. So this is about forever loop. Okay, and let us see the remaining, that is block statements. So what are these block statements? These in previously we have used begin end keywords to group one or more statements, two or more statements I can say. So this begin end are the keywords that I have used to group multiple statements. So we have here the sequential blocks, where whatever the statements that comes under the sequential block executes one after another. Okay, so we do have also the parallel blocks. That means sequential block or the parallel blocks, this comes under the category of block statements. So these block statements generally club or merge multiple statements to to have a picture that these statements comes under particular block. Okay, now coming to the sequential block, as I have already earlierly mentioned, begin end are the keywords. So whatever the statements I am having in my sequential block are processed one after the other. That means a statement will be getting executed only after its before or preceding statement completes its execution. And if I am having any delay or event control for any particular statement in the sequential block, that statement will be executed relatively to the simulation time when the previous statement in the block completes its execution. Like I will be explaining this point to you. Yeah, 1 second. So in this one I am having a sequential block. So W will be executed after the execution of this statement. That means this statement will be executed after this one. That means this one will be executed at time 0 seconds. This one will be executed at time 5 seconds. This is 15 and this is 35 seconds. So accordingly, that means I can say here each and every statement will be getting executed relative to the simulation time when the previous statement, that means for this one it is the previous statement in the block completes its execution. So this execution gets completed at 15. So here this execution is depending upon this execution time, this execution time completion. So after that one, this statement will be getting executed. Okay, so this is about sequential block. And so I will explain you in detail by using the program for the sequential block. So let me have some recap on the parallel block. You might have came across the blocking and I have only taught you blocking and non-blocking assignments, right? So in the similar manner I do have here sequential and parallel blocks. So I have used the operators. Here I am using some keywords. So begin, end are the keywords that will be used for the sequential block, and fork and join are the keywords that are exclusively used for the parallel block statements or assignments. So coming to the parallel block, whatever the statements you are having here, all will be executed concurrently. Like there won't be any order. That means ordering of the statement, like this one have to be executed or at some time, or that one second statement have to be executed at particular time, third one will be executed at particular time, will be completely controlled by the delay or event control assigned to that particular statement. Okay, so what is the meaning of this one is, you can able to see here. So fork and join, these are the keywords. That means these all are the statements constituting a parallel block. So Z will be getting executed at 10 seconds, W will be getting executed at 20 seconds, Y will be getting executed at 5 seconds, X will be executed at 0 seconds. That means our execution of the statement is completely here controlled by the delay control assigned to each and every statement. That is the meaning of this. Okay, so let me check out with the next one. Okay, nested blocks. Okay, before nested blocks, let me have some quick recap. Yeah, so this is a sequential block, no delay. That means you didn't find any, you won't be finding any delay here in your sequential block statements, because this is the sequential block, because these are under the begin and the keywords. So this one will be, so first X will be getting executed, next Y will be executed, next Z will be executed, next W will be executed. If you would like to see the execution, I will show you now. Paste, right? So let me save it. So I have said you that X, Y, Z and W, this sequential block execution E will be in a sequence manner. So at 0 seconds X executed, next Y executed, Z and W, that means X, Y, Z, W. So it had followed some particular order, whatever I have written in the programming code. You can see here. So for suppose, if the sequential blocks, that means the sequential statements are provided with some delay. delay control is assigned to each and every statement, like 5 delay control 10 20. So my suspicion is this statement will be getting executed at 5. Next, this one will be executed at 15, and the next one will be executed at 35. So we'll be checking now. Let me copy this code here from here, just paste it. So whenever here, one thing you should know that X will be executed at 0 seconds. That means the Y, Z and W status are unknown. Y will be getting executed at 5 seconds. That means here X status I know, as it was executed earlier. Now Y got executed. That means at 5 seconds, at or greater than or equal to 5 seconds, I will be having the known status of X and Y, where Z and W status are unknown. Similarly here, I will be having X, Y, Z status. I don't know what is the status of W, unknown state. And here also X, Y, Z, W, all the states I will be knowing here. So at 0 seconds, X, Y, Z and W. If you observe here, X is a known status. Known state I am having here. Y, Z and W are unknown values. And at 5 seconds, X and Y are determined. Z and W undetermined. At 15, X, Y, Z are known. And at 35, X, Y, Z and W, 4 variables, are determined. So this is about sequential block with delays. So let me discuss about the parallel blocks. So just copy, let me copy the code here from here, copy, paste. So as I have said you, the order of execution of statements in the parallel block is completely under the control of the delay assigned to each and every statement. Like you can see here, for each and every statement I have assigned certain delay. So the order of execution is completely dependent on this one. That means, can I say that this one will be executed at 5 seconds and this one will be executed at 10 seconds and this one will be executed at 20 seconds. So let me check here in the program 5, 10, 20. So 0, 5, 10, 20, right. So at 20 seconds all will be getting executed. At 10 seconds X, Y, Z. At 5 seconds X, Y only. At 0 seconds, right. This you can see. So this is about parallel blocks. So I just stopped the execution. If the parallel blocks are held provided with any delay in its statements, like I haven't given any delay here, here and here. So according to these parallel block statements, I may have a chance to face the race around condition. The race condition I can face. Why? Because here X 1 bit binary 0, Y 1 bit binary 0. That means all X, Y, Z, W will be executed at 0 seconds. That is fine. But I am not sure that which one among these 4 will be getting executed first. Like for example, X and Y, if they are executed first means Z will be having some finite value, W also will be having some finite value, because these finite values of Z and W will be received from X and Y known values. For our misfortune, if Z and W are executed priorly, then X and Y, what happens? Z and W are going to receive the unknown condition, which is the race condition, highly prohibited in the programming. So in order to overcome this one, we are going to give here delays. Delays are to be associated. Okay, so the very next one is nested block. I hadn't, let me go with PPT. So nested block, like I can club I can merge my parallel as well as the sequential block. The best example is displayed here, like initial begin x equal to 1 bit binary 0. That means inside a sequential block I am placing a parallel block. So how I come to know that it is a parallel block means I have taken here fork and join as the keywords. So fork hash 5 y equal to 1 bit binary 1. That means y will be executed at 5 seconds and z will be executed at 10 seconds, because these are the parallel block statements. And so among the parallel block statement, the highest delay is generated by z for its execution. So these have to be taken into account. So that means w will be in sequential block again. So parallel block execution, the greatest amount of time for the parallel block to execute its statement is 10 seconds. So this 10 seconds is the reference now. So w will be executed based on the reference time. So 10 plus, what is the delay provided to w here? 20. So 10 plus 20, at 30 seconds w will be getting executed. So this is about nested blocks. Okay. Similarly, we can also name any sequential or parallel blocks. That also can be possible here. So what is how to name any block? Like blocks can be given names. Like we are having two academic blocks, AB1 and AB2, and for example, like we are having some departments like CSC or ECE are the departments that belonging to AB2 block. In the similar manner, civil and mechanic civil department is there. So civil department is belonging to AB2 block. That means in a block I will be having a variables, and these variables are local to that blocks only. Like the departments are local to particular blocks, like EC department is belonging to AB2 block, civil department is belonging to AB1 block, like that. So these are the local variables that those completely under the particular blocks itself. So that means local variables can be declared for any named block here. So if I would like to access any particular variable, how I have to access? So variables in any named block can be accessed by using hierarchical naming manner. Like if I want to access any department, so first thing is I have to start from block. So if I want to access CSC department, that means I have to access AB2 block. After accessing the AB2 block, I will be accessing the CSC department, and after accessing the CSC department, I will be fetching the particular year and classroom in the CSC department. This is the order how I will be coming to access any classroom. So similarly, if I want to access any variable in a named block, I need to follow some hierarchical name referencing. And there is a chance to disable the named blocks also. Okay, like for example, first we'll discuss about the named blocks, and later we can have a, yeah, here I am having named blocks. So name module name block. So this is my module name is a name block itself. So I am having here two blocks, that is one is block 1 and this is my block 2. Otherwise I will be writing as AB1 block, AB1 BLOCK, it's better. In AB1 block I am having civil engineering as a department. So this is civil engineering. It is a static and it is local to AB1 block only. And if I want like to access the civil engineering means I need to access first AB1 block, and after that I can able to access the civil engineering block. Okay, so like in the once I have integer I have taken here, so civil engineering. So the total number of students in the civil engineering block for any particular year is, let me go with 190 students. So 190 students or 120 students like that. Okay, so in the similar manner I am having one more block, that is AB2 block. AB2 block. So I have to give some variable j I have taken here. Instead of j, let me go with ECE. ECE is the variable. So the total number of students in any year in ECE branch will be around 190. Typically, not roughly I have taken here 190 as the count, here 120 as the count, roughly. Okay, so if I want to access the number of students in particular department or particular variable means, definitely I have to come from hierarchical naming reference. Like what's the block here, module name num block in num blk name blocks. Okay, next ab1 block, ab1 block. Okay, so what is the variable here in the AB1 block? Civil engineering is a variable. In this manner, I can able to access what is the count of number of students in any particular year. Okay, so name AB1 block, AB1 block dot CE equal to percentile M. So percentile M is used for hierarchical reference. Okay, so hierarchical naming or referencing purpose we are going to use this percentile M. Now I equal to, instead of I am just replacing with CE, that is civil engineering. Percentile D also I can use because it is an integer, right? Decimal. So block 1, that is the hierarchical naming should be definitely important. NMBLK dot AB1 block dot, what is the variable here, civil engineering, comma. So again, what is the count of civil engineering? I am writing here explicitly. This is okay. So AB1 block I have taken as a sequential block. Why? Because begin end are the keywords I have used. And for the AB2 block I taken under parallel block structure. So where 4 can join are the keywords I have used, register ECE. So reg ECE integer means CE equal to 120, it is supporting. Okay, instead of 120 or 190, let me go with C equal to some 4, and here reg I have taken, it is treated as a scalar quantity, because if I mention like reg 1 down to 0 or 2 down to 0, it's better. That means now it is a 3-bit quantity. ECE is a vector, so ECE it is a vector means ECE equal to 7. So now it satisfies. So just let me copy down this entire thing from here to here, copy and paste, Control V. 9 block hierarchical naming reference, that means from module name, next block AB2 block, next particular variable in that block, that is ECE, and so this is for hierarchical naming referencing, and this is the number of what is the value or the value of that variable, like CE is the variable, it is the ECE is the variable here, and this is the value. Name block dot AB2, I can write AB2 block dot ECE and the value of ECE. First one is hierarchical name referencing. Second one is what is the value of that variable. Okay, this is the one you need to remember. So once again I am going to explain you in the program. Copy and let me paste here itself. Paste. So module name block. Name block is the module name initial. I have used it here to so this is first block, this is first block, and this is my second block. Okay, so this second block is a fork and join, it is a parallel block. First block is AB1 block, it is a sequential block. Okay, let me remove all these things. Yeah, now I will explain once again and we'll start execution. So name block is the NM block is the NNPLK is the module name, AB1 is the block name, okay, and AB2 is the block name. So because begin end it is a sequential block, fork and join it is a parallel block. For the parallel block I have given the name as AB2 block, for the sequential block I have taken the name as AB1 block, and in the AB1 block let me declare some local variable, that is a CE. Of course it may be some random variable or like a department, or you can assume anything. So CE is the variable and it is an integer type. So CE equal to 4, and so the value of CE can be displayed like this by using $display. So $display particular, that means these two blocks will be executed parallelly. Why? Because initial, I am having two different initial blocks. Each and every initial block will start execution at time 0 seconds onwards. So $display $time. So I want to refer CE means I need to come from the hierarchy, like what is the module name and what is the block name and what is the variable name. In this way I can able to trace out what is the value for CE. First thing is hierarchical naming reference. So after that after that the value, that means what is the value of the variable. So value of the variable and hierarchical naming reference, this kind I can able to see in the display window, okay, console window. And similarly for block 2, AB2 block, this is EC is it is a vector register variable 2 down to 0, that means the maximum value is 7, that is 111, and the minimum value is 000. So the value I have given to my register EC variable is 7, and this value can be ECE equal to 7 can be displayed by writing the instruction in this manner. So that means ECE is local to fork and ECE is local to AB2 block, CE is local to AB1 block. That is the difference. So join end module. So let me run the program. Yes, so 4 and 4, okay, nice. So of course I have written twice in the $display. So name block ab1 dot block dot ce equal to, right, this is okay, ce equal to 4, right. It is same 0 seconds amount of time, name block dot ab2 block dot ece equal to name block ece equal to 7 and 7, right. This is also right. So you can able to see here I have written twice there, that is why I have got 4 and 4. That means whatever you are going to see in the console window is completely dependent on whatever you are going to write in the $display. Okay, so be careful and cautious whenever you are writing something in the $display. That is what I would like to say. and this E is local to AB1 block. That means E variable is local to this AB1 block and this E variable is local to AB2 block. So for example, if I would like to access ECE from AB1 block, whether it is possible or not, we'll check. .ece, like I have given like this. So let me save, simulate. Like hierarchical naming reference, it will never be possible like here. Okay, so sorry, I need to make certain change here also. So not here. Hierarchical naming reference. Because from AB1 block I am going to access ECE variable, whether it is possible or not. No, it is not possible because ECE is not coming or it is not declared under AB1 block. That is why we are going to get here the error. So this is about named blocks or unnamed blocks. I mean named blocks by using sequential and parallel. Okay, so sometimes how to disable these named blocks also plays a vital role. So let me copy this example from here. So copy and let me paste here. Okay, let me save also. So before it, let me explain you what is this disabling a named block. So if I would like to terminate the execution from a named block, I am going to use the keyword disable here, disabling a named block. That means to get out of a loop. So what happens generally whenever I am using this disabling a block? So it causes my execution control to be passed to the statements that are present immediately after my block, after my named block. Okay, like for example in your C programming language, you might have used a break statement to exit or to come out of the loop. In the similar manner, here also I will be using the disable to come out of my execution of that particular loop. So the disabling and break here, one break is used to exit from the loop, disable is used to bring or disabling or of execution of any named block. That is the main difference for the two. Okay, so let me explain you with an example program. Okay, so here I have written already. So instead of a flag register, I have taken as a 16-bit register. Instead of it, let me take as 5-bit register, 4 down to 0, and it because it is a 5-bit register, and let me go with 5-bit binary. Yeah, it is a 5-bit binary 0 0 1 0 0. So 0 1 2. Its second position I am having here 1. So I equal to 0 while I is less than 5. Right, everything is right here. So what is happening in this disabling a named block? I have taken a flag register variable which is a vector, 5-bit vector it is, 4 down to 0 it is a 5-bit vector, and I have used one more variable that is I, which is of type integer. Now initial, so whenever initial begin, so I am initializing something to my variables. For variable flag I have initialized it with 5-bit binary 0 0 1 0 0, and initial value of I have taken for I is 0. Now begin. So block 1 is the name I have given to the sequential block while I is less than 5. What is this I here stands for? Flag is a 5-bit vector. So whose lowest index is 0, lowest index is 0, highest index is 5, like 0, 1, 2, 3 and 4. So I equal to 0. When I equal to 0, that means the 0th position is 0. When I equal to 1, the first position is having the value of 0. When I equal to 2, the second position or the second bit position is having the value of 1. And similarly, third bit is having 0, fourth bit is having 0. So similarly, like begin block 1 while I is less than 5. So what is the first value of I? 0. Begin. If a flag of 5, that means if flag of 0. If flag of 0 means the corresponding index of this flag register. If flag of I is true, flag of 0. Is this flag of 0 is 1? No, it is not 1. So if it is not 1 means this statement why will they will be getting executed. No, right? Okay. So this statement will never be getting executed. Simply I equal to I plus 1. Increment the I value now. Now I equal to 1. Now again check. Flag of 1. Is it true? That means flag of 1 is equal to 1? No. Flag of 1 is equal to 0 here. Like you can able to see. Flag of 1 is 0 here. So simply this also won't be getting executed. So again increment the I value here. I equal to I plus 1. Now I equal to 2. Now if flag of 2 is 1 or it is a true, yes it is true. So begin $display encountered a true bit at element number percentile d comma I. That means in the display what you are going to find in the console window is encounter a true bit. That means what is the true bit here? 1 is the true bit at a element number. What is the element number? At I equal to 2, so comma I. So this is what happens. So once it is encountered, immediately I need to exit from the loop. Like I need to disable or I have to complete the loop. I have to stop the execution and come out of the loop. So that means here I have used disable which makes me to get out of this loop, okay, or to terminate the execution of this block 1, that is named block. And so I will be getting here, my control will be going to somewhere else and I will be coming out of the loop. Let me run the program. So at the second position, right, I have found encountered a true bit at element number 2. That means at I equal to 2 I have found a true bit. So I have as soon as I have found a true bit, I got my control out of the loop and I stopped terminated the execution of that named block. So at I equal to 2. So whatever the thing that we are writing in the $display, that only will be displayed in your console window. So you should be cautious. So that's it, students. This is about named blocks or block statements. So by this we successfully completed discussing various constructs that will be helpful in structuring any hardware design by using the behavioral abstraction. Okay, this is the task that I am going to assign you. So what is happening here? What is this program? As soon as you see the program, you need to tell me what is the functionality or what is the behavior of this program. As soon as I see this, I can feel that it is a tray bit counter. That's it. So this is about behavioral abstraction. Okay, thank you for the day. Have a nice day.